Everybody stand for the opening prayer and let us feel the presence of the Lord. Amen. Good morning, class. We are the reporters from Group 2 and I am here to discuss one of the topics in linear transformation that we will cover, which is the isomorphism of vector spaces. And before we proceed to our lesson, let us have first the objectives so that we will be guided as we go along to our discussion. Everybody, please read. Thank you. A vector space is a mathematical structure that consists of a set of objects known as vectors. Along with two operations, vector addition and scalar multiplication. Vector addition combines two vectors to produce a new vector, while scalar multiplication scales a vector by a scalar, a real number. So the term isomorphic comes from the Greek word meaning of the same form. In the context of vector spaces, isomorphism refers to a specific type of relationship between two vector spaces. When two vector spaces are isomorphic, it means that they have the same structural properties and can be considered essentially the same. So the relation of isomorphism is an equivalence relation on the set of all vector spaces. So the relationship where two vector spaces have the same structure and can be considered equivalent. Now, the isomorphisms are a fundamental concept in linear algebra that deal with linear transformations between vector spaces. When a linear transformation is both one-to-one and onto, we call it an isomorphism. Now, let's go through the definitions and explain them further. So an isomorphism is a linear transformation that satisfies two conditions. It is one-to-one, meaning that each input vector corresponds to a unique output vector. So, ganito siya. It is onto, meaning that every possible output vector in the target vector space can be reached by applying the transformation to some input vector. So, ganito naman pag si T ay onto. Sa madaling salita, ang isomorphism ay nagpapakita ng pagkakapareho between those relationships sa pagitan ng mga vector spaces, kung saan ang bawat input vector ay may katumbas na output vector at ang lahat ng posibleng output vector ay ma-achieve lang natin sa pamamagitan ng pag-a-apply ng transformation sa ilang input vector. Okay, when we say isomorphic, when a linear transformation T is an isomorphism, we say that the vector spaces V and W associated with the transformation are isomorphic. This means that they have the same structure and can be considered essentially the same. Now, let's analyze why T is an isomorphism in the given example. Number 1, T is one-to-one. To prove that T is one-to-one, we need to show that if the linear transformation T maps a matrix A to the zero matrix, then A must be the zero matrix itself, where A is a square matrix of size 2 by 2 with integer entries. In other words, we need to demonstrate that the only way for the transformation to yield the zero vector if the input matrix A is also the zero matrix. So in this equation, a system of linear equations that can be written as T matrix element of A, B, C, and D, we can solve this system of equations by using matrix multiplication. So the only solution to the system of equations is A equals to B equals to C equals to D is equal to 0. This means that the matrix A, B, C, and D must be the zero matrix. That's why T is one-to-one. So number 2, T is onto. To prove that T is onto, we need to show that for any vector x in R to the 4th power, there exists a matrix A. So in other words, we need to demonstrate that every possible output vector can be achieved by applying the transformation T to some input matrix A. Since we have shown that for any vector there exists a matrix A such that T A equals to the vector, which can conclude that T is onto. Next, since T is a linear transformation that is both one-to-one and onto, we can conclude that T is an isomorphism. So this means that the vector space are isomorphic. Now, let's verify that T is linear. To do this, we need to show that T satisfies the following two properties. So, T times to the quantity of K, A plus PB equals KT times the quantity of A plus PT times the quantity of B. For any scalars K, P and matrices A and B. Therefore, T satisfies the first property. Now, let's verify the second property. Let A, B be matrices, therefore T satisfies the second property. Since T satisfies both properties, we can conclude that T is linear. Now, let me ask you a couple more questions. Can you think of any real-life examples where isomorphisms might be applicable? How do isomorphisms help us understand the relationship between different vector spaces? So to answer that, think of isomorphisms as the secret code that reveals the hidden relationships between vector spaces. They provide us with a common language to bridge the gap between the seemingly unrelated areas of study. So just like how knowing a secret code allows you to communicate with others who understand it, isomorphisms enable us to communicate and transfer knowledge between different vector spaces. Okay, let's move on to our activity entitled What Am I? So in this activity, you will guess the answer based on the given definition. So let's start with question number 1. The answer is isomorphism. Very good. Next, the answer is one-to-one. Very well. Next, the answer is onto. Wow, fantastic. And for the last one, the answer is isomorphic. That's great. So I'm glad that I was able to share some knowledge with you. By understanding isomorphisms and the connections they reveal, we unlock a world of possibilities. That will be all, and have a blessed day. Thank you.